Okay, here we have a function h of x, and it's a rational expression. And first thing we would do would be to look at the direct substitution if we're interested in finding what's happening at various points. If we're looking here, what's happening at x equals 2, all right, we would do direct substitution into the numerator and the denominator. And when we do that direct substitution into the numerator and into the denominator, we see that at 2, they're both equal to 0. We can see it on the graph, the red and green graph, and we can also see it over here at the number f of 2 is 0. G of 2 is also equal to 0. That's the numerator and denominator. And the function itself, h of 2, is undefined. Alright, so if we put in 2 into the h function, we're going to get a 0 over 0, which is the indeterminate form. Since it's the indeterminate form and it's continuous around this area except for at 2, we can apply L'Hopital's rule. So L'Hopital's rule is to take the derivative of f in the numerator, derivative of g in the denominator, and then see if we can do direct substitution there. Well, that function f prime of x divided by g prime of x is this function in purple. All right, and if we do direct substitution into this new function of the value 2, we get a value of 13.33. all right. And so by L'Hopital's rule, then we can assume, not assume, but be sure that the limit of the original function h of x, that the limit of that function at x equals 2 is equal to the same thing, 2, 13.33.